My name is David Ferriera. I work at ForgeRock. We're an open source identity and access management company. We're actually headquartered in San Francisco, about 8 blocks from Pivotal. Been there many times myself, so we're fairly close. I'm going to be talking today about authentication and authorization architecture in this microservices world that seems to be coming on whether we want it to or not. This is a 30-minute talk, so normally when I give this to customers it's quite a bit longer. So I've stripped it down, and hopefully this will give you at least an idea of the formula that's involved in some of these processes and some of the variables in that formula that you can tweak to meet your security or performance needs. Now, whenever I start talking about identity, I want to make sure we understand what layers of identity we're talking about. There are several of them. Starting at the top, you have the largest one. It's kind of a reverse pyramid here. At the top is the biggest one with users, devices, things, applications, and services. These are the things that are consuming externally exposed applications or APIs. This is the layer of identity that needs the most scale and is the most complex. You have different types of protocols involved. We'll be talking about that today. As you go down the stack, you have the service layer where you have mostly service-to-service discussions, applications talking to services, services talking to external services. And again, these layers, they all have their own authentication and authorization systems. Maybe they're the same system. Most often, you don't have the same system going down the whole stack. There are usually several of them. Moving down the stack, we move to the platform. So if you were familiar with Cloud Foundry, you're a developer, you may be doing CF push. You may be working with Dev Manager if you have Pivotal Cloud Foundry, or whatever tools you have for your platform. But developers are going to have to authenticate and authorize to that layer as well. And then you go on down to the operators. These are the guys who are on call and managing the infrastructure, if you will. So in a Cloud Foundry instance, that's Ops Manager or Bosh. Traditionally, it's SSHing into VMs or bare metal. But again, a different authentication authorization mechanism. When we start talking about microservices, these are the two layers that we need to talk about. Both of them will be involved and need to interact together in order to have end-to-end security. So if we kind of translate these layers and start looking at what that means for microservices, you might start out with your Pivotal Cloud Foundry platform, and you might deploy an application and some microservices. You have some external services to talk to, data services, authorization servers, messaging servers, what have you. You start off this way, but we're all agile, right? So every 2 weeks we have that sprint demo and we got to deploy something. So before you know it, you end up with this. And you have lots of microservices in multiple layers talking to each other. And what this ends up with, as you see it, have a user coming through, a single user transaction to your front-end application, and that application ends up talking to a couple of microservices, and they talk to 2 microservices, and before you know it, you have this chain of calls, all initiated by that single user call. And oh, by the way, your microservices have to talk to these services, and they all have to do this. So before you know it, you have something that looks like this, just generated from a single request from a user. As you can see, this is a different world in performance as well as security from the old monolith days where you came in the front door, we secured the front door, you did some stuff inside and returned it. Now we have this chaining effect that depending on your method of management, you may not always even understand how many calls a single call to the front end results in. So again, you have different requirements now for performance and security, and they have to be balanced. Each one of these calls is going to have to be authenticated, and each one of these calls is probably going to have some sort of performance SLA, so that you know when you're building your applications out of these microservices, you can calculate the latency. So if all of my microservices have a 5 millisecond latency, well, I know I can use this many before my user goes away. And not only do they need to be authenticated, but they need to be authorized too. So especially when you get into these complicated scenarios of microservices talking to microservices, you may not want every microservice call to have full access to every microservice. Not every user will have access to everything in your system, and so we usually have some type of role-based access control. That's pretty traditional. I am an admin, so I can do this. I'm an owner of a tenancy, so I can do that. But again, as we start breaking this up into smaller and smaller pieces, we start finding that we need more fine-grained access control. So one of the things we do with OpenAM, our access management product, is that we have attribute-based access control, which means any attribute that we store or any attribute that we can gather in the transaction, such as a device ID or a user agent, all of those can be used as an authorization policy. So we have very many capabilities in here to fine-grain control what a user or a service can do in your service. Now, one of the things I'm going to start talking about over the next few slides are some of the elements of this architecture that you're going to need. And one of the things I've had to strip out is deep explanations of these protocols. Luckily, earlier in the week, Shri and Philip from Pivotal, maybe some of you were there, they had a talk about these protocols, and they did a really good job explaining OAuth and OIDC. So I think if you're looking at these afterwards, you should pair our two talks together. I think they will help each other. So OAuth is the common protocol used for service to service. And in our specific case, we're going to use the bearer token usage. And to sum up a very long RFC in a sentence, it basically says anyone who's bearing the token, it will be honored, as opposed to we're going to go validate against some server or something. OpenID Connect is a newer protocol, but it's coming on very fast as protocol of choice over things like SAML. It's built on top of OAuth 2. It just adds an additional token and some flows to that. So these are the protocols that we'll be talking about, and you'll see them as I go through some of the sequence diagrams later. Along with the protocols, we have tokens, lots and lots of tokens. And as you see in the sequence diagrams, when I get there, there's going to be tokens all over the place. And sometimes when you're working on your microservices, you may say, what in the heck are all these tokens about? So hopefully I can shed some light on some of those things. The first two tokens are coming from the OAuth spec, an access token and a refresh token. You get both of these. And then you have some options here in access tokens. They can be opaque or they can be a JOT, a JSON web token. An opaque token would be just a random string, and the server would store the session information that's related to it. Or with a JOT, you can actually put information in the body. They can be stateful or stateless, and we're going to talk about that a little more. And all of these tokens have time to live. And so this is one of those variables you're going to be able to tweak based on your security and performance requirements. When an access token is expired, you have a refresh token. And so you can send a refresh token to the authorization server and say, I need a new access token. So that's the role of the refresh token. Again, as part of OAuth, you can use this token without credentials. So you've given credentials to an authorization server, and the authorization server gives you these two tokens back. And now you can just use the refresh token to get new access tokens. That is until the refresh token expires itself. So again, there's another time to live, generally, and hopefully it's longer than the access token. Otherwise, it's not super helpful. And this must be stored securely, because this is the token that allows you to get more access tokens. So if you have a time to live of hours and you don't store this securely, that means for hours somebody can be getting valid access tokens on your behalf. So you've got to store it securely. OIDC adds yet another token on top of this, which is the ID token. And this contains the information about the identity that has been authenticated. This must be a JOT, although I left off the T. Generally, this has an even longer time to live, because this is usually a human being on the end who is logged into an application, and that session usually lasts a little longer. But you can see here that you have 3 time to lives within these tokens that you can tweak to meet your security requirements. Formats of tokens, like I said before, they could be opaque, but they could also be JSON Web Tokens. JSON Web Token is a standard. As the name suggests, it's JSON. And there's multiple levels of security, so there isn't just one standard here. If you look, there's a list of standards this long that have to do with what you can do with these tokens. You can encrypt them multiple ways. You can sign them multiple ways. You can do key management in multiple ways. So there's lots of possibilities here. We're going to start out with something simple in the architecture that we're discussing here, though. Usually these are stateless, so that the consuming body can just open them up and consume them as is. So some of the choices you're going to be able to make between performance and security, the first one being stateful or stateless. A stateful token, the session is managed on the server. This is how traditional sessions are managed if you're running traditional Java applications. The opaque session ID might be in the URL or in a header or somewhere else. And then when it gets to the server is actually managing that state and keeps track of all the data that's implied in there. The token is opaque. Tokens must be validated with the server. One of the advantages of this method is that there's better logout. So if you're checking with the server every single time, it's easy to have a logout because the token is validated every time. So that's one of the things that's more difficult with a stateless token. The other type of token is stateless. Sessions are not stored on the server. And these tokens are usually JOTs, where they have a body that has information in them that the consuming microservice can act upon. Again, they're validated locally, and the microservice has to do the authorization itself, whereas in a stateful token, the server can do that authorization for you. So usually in a stateful token, you can have more advanced authorization going on because you have a whole server that can have more capabilities. But if you can narrow your authorization requirements down to something simple, then you can do it locally within your microservice. Spring has some good capabilities for this. They have injectors and filters and things that you can use in conjunction with this to manage that. Like I said, the tokens are difficult to revoke before the time to live because they're stateless. You're not checking with the server every time. So again, those time to live start to become important. You may want to tweak them over time to make sure you're meeting your security needs. Unfortunately, often you're choosing between performance and security. So I know what your security guys will say. They'll say, well, security every single time. The developers will say, well, if we're so secure that the customers are going away because our site is slow, well, then who cares if we're secure? So it's this balance that you have to strike. And these are some of the things you can tweak to make that choice. Again, like I said, one of the options is a stateless or stateful token. We talked about that. You can encrypt the body of the JOT if you require more security. So especially in a stateless token, you can encrypt the body such that if someone gets it, they can't really do anything with it. Obviously, you have to decrypt the body, so that's not as performant. You can validate with the authorization server every time. That's more secure because it's more up to date, has the latest amount of information. But again, it's faster to just use a stateless token and check the signature on the microservice and do it locally. As we're going to see, there's multiple tokens in this stack, and you can choose to validate all of them, and sometimes you might not. If you remember the layers as you go down, maybe you're at a layer where you can assume that a microservice above me has already validated one of these tokens. And again, these are choices based on your security requirements. Everybody has different requirements. We don't try to tell you what to do. We just try to give you the options and hopefully be able to say yes for every one of those options. And again, the time to lives. Longer is more performant. You're not having to refresh tokens more often. Shorter is more secure because there's less of a window of attack. So these are kind of the variables that you can play with. Let me show you if you have OpenAM configured for stateless tokens, this is the response you'll get from an OAuth request. You can always see the JOTs It's probably not very big up there, but they're separated by dots. I tried to make them red and bigger, but they're not too big. But generally, if you get a bigger token, it's probably going to be a JOT token. The opaque ones are usually smaller. And again, you're going to get both the access token and the refresh token and some metadata in there. This is what they look like. Not very helpful in that format, so I recommend going to jot.io. It's a really good resource if you're working with JOTs. Lots of good documentation there. Also a good list of pretty much all the libraries you can use in every language to work with JOTs. And also they have this decoding tool, so you can just drop your JOT into here, and if you drop the secret that it was used to sign it, it'll unpack the body. So if you see the payload in the middle, that's what the access token in the previous slide looks like. And you have lots of options for what you can put in here. And this is, again, one of those variables that you can play with. It's possible to stick a lot of user profile information in there so that your microservice doesn't have to make a call to a user profile service. So that would save you another call. That has to be balanced with the size of the token that's going around. So if you put too much stuff in here, every transaction is going to be carrying this heavy payload of token around. So measure that against your other requirements. You'll notice in here that there's some of the information is common amongst all of them. There's expiry, there's the time it was issued, and so when you're doing stateless tokens, you have to pay attention to that. So if the token is expired, that means it's invalid and you shouldn't use it anymore. And that's kind of up to you to validate, because again, the server's not validating it for you in a stateless architecture. That said, most of the libraries out there, they know how to look for this, and they'll just tell you this was an invalid token, and you can send the appropriate 401 or 403 response. So let's look at what one of these transactions looks like. This is the simple one. This is a service-to-service call with a bearer token. We have Microservice 1 that wants to talk to Microservice 2, and we have the authorization server in the middle. Now, if you were using Cloud Foundry, this microservice will probably be able to grab client credentials from the environment. This is one of the things that ForgeRock is working on, is a service broker that will allow Cloud Foundry apps to bind to an OpenAM authorization server, and your credentials will just appear in your environment. You grab those credentials and you request a token from the authorization server, and again you'll get 2 tokens back as well as some of that metadata in the response, and then you send the access token along with the request. And now in a stateful architecture, the microservice receiving the token has to go validate that token with the authorization server. So you now have to use their own client credentials to talk back to the authorization server, sending the token they received for validation, and if it's valid, then of course they can act accordingly and send the data payload back. So this is what's happening underneath the covers when you're doing these OAuth calls. It's not always apparent sometimes when you're using libraries and things are abstracted from you, but these are the calls that are happening underneath the covers, and these calls aren't free, right? They're all network calls, and they take time. So before I go on to the more complex situation, I want to take an identity view of microservices. Now this is just a logical view. Your normal microservices architectures, whether you're doing chaining or branching or proxying, that all applies. This is just a logical view based on identity requirements of your microservices. So those tier 1 services kind of go along with the tier 1 requirements in that first slide I showed with the layers of identity. They're exposed externally and internally, and they require consumer and service identities, and you need a higher level of security. So these layer of services are probably going to validate all the tokens. And at this layer you may choose to validate them with the server because you want a higher level of security. But as you move down the tiers, you may have internal only microservices that aren't exposed. And again, everybody's architecture is different. Maybe your services are all exposed to the public, in which case you have all tier 1 services. But we find with the customers that we're talking to, they often have backend services or internal services that don't require exposing to the outside world. So these are going to be called from other services internally, and so they're going to require service identities, but maybe these services also need to know who the end user was. And they need to know who logged in because that user has specific permissions, or that user identity allows them to scope their queries properly. If you're doing reports or what have you, you may need to know who the person is who's getting the report to determine what reports they can get or what data they can see. So that's sort of a tier 2 service. And then at the bottom you have tier 3 service, and these services may not even care who the user is. Maybe they do, maybe they don't. But maybe, again, it's just a query of data, but it's already been scoped before getting to this service. And so this tier of service probably doesn't even need a consumer identity, and it can just handle with the service-to-service identities. There's many ways to slice this microservice thing, and there's no standard way of doing it. This is just something I find when I'm talking to our customers, that they start to fall out into these types of services. So let's look at the composite service use case. This is what I described earlier, where an end user is coming to your application, and your application is going to make a call to a service. So again, this is composite, and so there's two identities involved in here. There's the user's identity, and there's the service identity. The first flow here is going to be the OIDC flow described earlier. And there's quite a bit of back and forth in this flow. This is the authorization code if you're keeping track. The user shows up at your application for the first time. Application's protected. They don't have a token, so they get a redirect back to the authorization server. And here the user is going to have to put in their username and password. And since this is OAuth 2 based, they'll also have to give their consent to share their data. You'll see that a lot now in Facebook and Google types of logins. They'll say this application wants to access this data, yes or no. If you say no, you don't get access, so you always say yes, but that's the way it works. Once that's validated and you've given consent, there will be yet another redirect back to the application, but this time we'll have an authorization code. This is not a token, it's just a string. It's not good for very long. And that application is now going to use it against the authorization server to get the tokens we described earlier. So they're going to get back an access token, a refresh token, and an identity token. And in a stateless world, they're all going to be JOTs. So it's going to be a JSON payload with 3 JOTs inside of it, as well as some metadata. And the reason for this flow is you saw that the user's credentials never went to the application, and that's sort of the biggest security portion of this flow, is that you don't want that application to have the user's credentials. All they ever got was a code from the authorization server. Credentials passed between the user and the authorization server only. They didn't pass through the application, so that's the reason for that flow. But you can see there's quite a bit of back and forth there before we can even begin. That's 3 or 4 connections just before we can begin. So now the application has their 3 tokens, but the application itself has to authenticate to the next service. So it in turn now, if it didn't already have one, I'm starting from the beginning, if it already had one, it would just use it. But if it didn't already have one, it would use its client credentials, go to the authorization server, get back its 2 tokens. So now the application has 5 tokens. So you have to keep track of what those are. You have 2 access tokens and 2 refresh tokens. So it can be a little bit taxing. So now we're going to call the next web service, sending 2 access tokens and an identity token. 1 access token for the user, an access token for the application, and the identity token of the user who's calling. So since this is a stateless architecture, the tier 2 service is just going to unpack these. It has a shared key that hopefully it got from its service broker and is grabbed from the environment. With that shared key, it's going to validate the signature of these tokens. And once they're validated, it will unpack the identity token and act based on the information it finds inside. And it will return the payload back to the application. The application returns its payload back to the consumer. So that's a lot of back and forth just for authentication and authorization. But if you want to be secure end to end, that's what's going on beneath the covers. Now, let's start talking about Cloud Foundry for a little bit, because ForgeRock is working a lot with Pivotal and some of their features that they have in their platform. One of them that has been released this year is called a route service. How many people know Cloud Foundry in the audience? Okay. I'll explain some of it then. So if you, inside the Cloud Foundry platform, you have a couple of components that they provide. One is the router. Every transaction that goes into Cloud Foundry goes through that router. The cloud controller, as the name suggests, controls running processes and manages credentials. So if they have a concept of a service broker. If you want to talk to an external service, you have to bind yourself with a service broker to that service. The cloud controller will then put environment variables in the environment of your microservice, and then you can just grab them. Again, one of the goals of Cloud Foundry is for the developer not to have to worry about any of this stuff. You don't have to keep track of where your endpoints are. You don't have to keep track of your credentials. Cloud controller does that for you. You just grab them from the environment and use them. And if they change, then they get changed, and you use the new ones that arrive. So one of the things they have now is a route service. So by default, transactions that go through the router are not authenticated or authorized. As the name suggests, it just routes transactions to the appropriate location. So that's why we were seeing microservices themselves do the authentication authorization themselves, because there's no layer in front of them to do that. Now with a route service, you have the ability to bind a route to your application, and that route service will call out to whatever is bound to. So one of the things we're working on at ForgeRock is a route service that will call out to our Access Manager product, and you can do several things. One, you can do the authentication authorization at the router before it even arrives at your application or microservice. And then based on your security requirements, you can decide whether or not you want to trust that or whether you want to validate it again. It's up to you. One of the deployment recommendations from Pivotal is that you deploy your runtimes in a private network. So maybe that's good enough for your requirements, that none of those runtimes are directly addressable. Maybe it's not, depends on your requirements. But we can make a call out based on your application, based on your policies. You can have a specific policy for your applications, and they can be applied at this level before it even arrives. Another thing we're looking at is the ability, we saw the JOTs and they had a body. Well, one of the things we could do at this point is, based on your microservice requirements, is that we could inject more information into that body based on what you need. So if there's more data in the user profile that you need for your microservice, based on policy, we could inject it into the token at that point. So when the token arrives, you unpack it, and the data you're expecting to be there is already there. Again, you don't have to make a call to the profile. So this is something we're working on and expecting to deliver this year. And then we've been working on service brokers for a while now. So we have an alpha service broker out now. Their code complete on a GA service broker should be released any week now. And then we're also going to do a tile for those Pivotal Cloud Foundry folks. And then we're going to enable some other flows as we go forward with these service brokers, with the route service being delivered at the end of the year. This is one of those things that really makes Pivotal a great platform, is this ability to remove requirements from the developer. So you don't have to worry about where your external services are. You don't have to worry about where your database is. You just bind to a service broker and use the data. It's very powerful, and if you haven't taken a look at it, I suggest you do. ForgeRock's open source company. You can download our software, use it on your own. I recommend you go there and take a look. We have 4 products actually: an access manager, a directory server, an identity gateway, and an identity management product. And here's some references for those things that I skipped over really fast. And that's all I have, and I have time for questions, amazingly. I did it in 20 minutes, 30 minutes.
A question.
Yes.
So let's say in my org I have several microservices and they are all resource servers. And how it works is that if I am going to have, and these resource servers are protected, their APIs are protected based on scopes. Okay, different type of scopes. Now, how would I have the clients that are registered with the auth service know, how would the clients know about the scopes? Like which, you know what I mean? So I have one microservice, which is a resource server, and it has multiple scopes assigned to the APIs. Now I want to register a client with the auth service, and I want to say this client to have X, Y, Z scopes. How would it know about those scopes when this resource server is the one with the
Well, there has to be some coordination at the end on scopes, right? It's not, there's no scope discovery service yet. I'm sure someone's working on a standard, they always are. But today there has to be communication and say these are the scopes, and then when you register the client, you can say these are the scopes for that client.
Who takes the ownership? Is it the client detail that's getting registered with the auth service, or the resource server who's protecting the APIs? Who takes the stand on the scope definitions?
So scopes are going to be attached to policies in the authorization server, but it's the resource server that is serving up the resource, and so you want to be able to say you must have these scopes or you can't get in.
So I have to coordinate with the resource server.
Yeah. Yeah. Question?
In that sequence diagram, you got app1 sending 3 tokens to app2. How are those 3 tokens bound together so that app1 couldn't, let's say, mix them up in this case? Is there any assurance that app2 is seeing these 3 tokens announced together?
Again, part of this is your security requirements and how comfortable you are with what's going on in your internal environment, right? So is it possible that that application, hopefully written by someone on your team, is going to swap out tokens? Only if it has access to get valid tokens as other users, right? Because even in a stateless architecture, you're validating the tokens. They're signed, and they have to be signed by the appropriate key. In order to get them signed, you'd have to have the proper identity to do that. So at the beginning, there is an authentication to get those tokens, right? So you can't get a token as someone else unless you have their credentials. Or you've stolen their refresh token, and within that time to live, you went and got an access token on their behalf. Hopefully your own applications wouldn't be doing that, but it's possible. Now if you've exposed it externally, then that's a concern, and now maybe you won't do. That's why I mentioned externally you may not do stateless, you may do stateless internally, and you may want to do stateful externally. So again, depending on your requirements, that's how you turn these. You guys go on. I think I got to get out of here so folks can get up. Thanks everyone.